All right, 4.3 is about proving parallelograms. Now, 4.2, we knew we had the different shapes and we applied the properties. Now, we don't know what we have. So this is how we take a random quadrilateral and we guarantee it is a parallelogram, a rectangle, etc. And then we get all the properties from before. So make sure you're always paying attention to what you know and what you want to prove or what you get. So the first thing is we need to prove we have a quadrilateral, or from a quadrilateral to a parallelogram. We know we have some four-sided figure. We want to prove it's a parallelogram. We know how powerful the parallelogram is. There are 5 ways. Now, you only need one to prove a quadrilateral is a parallelogram. Okay, you need one of the following 5 criteria. So if 2 pairs of opposite sides are congruent, then it's a parallelogram. So your picture, if you have a quadrilateral and you can prove this is true, you can conclude that it is a parallelogram. If you can prove one pair of opposite sides is equal and parallel, then it's a parallelogram. And notice they have to be the same sides. So I would have to know this side and this side are parallel and congruent in order to conclude that that quadrilateral is a parallelogram. The third way is if I know if the diagonals bisect each other, then it's a parallelogram. So if I have this diagonal and this diagonal, and I can prove or know that happened, I can say that quadrilateral is a parallelogram. You should be noting that these are our properties of our parallelograms. They're just provided in the converse, in the same way that we had the parallel lines and the angles. If I know parallel lines, I get angles. If I know angles, I get parallel lines. These are being presented as the converses of what we did yesterday. If, criteria 4, both pairs of opposite angles are equal, then it's a parallelogram. So if you can prove or show that to be true, then you can say you have a parallelogram. And lastly is our definition. If both pairs of opposite sides are parallel, then I have a parallelogram. And that is the one that we are used to from the definition. So those are the 5 ways to take a random quadrilateral and guarantee, prove it is a parallelogram. Now, we have the same set for rectangles. If you know you have a parallelogram, got to know that parallelogram first, then we can use one of 2 criteria to prove a rectangle. And again, we only need one. So the first one is if one angle of a parallelogram is a right angle, then the figure is a rectangle. Now, if you think about that, I know I have a parallelogram. If if one angle and one angle only is given to me as right, I can say it's a rectangle. Now, to go through the proof of this, if you think about those same side interior angles being supplementary and opposite angles being equal, you could prove that it's a right angle. This allows you the shortcut to not have to go through the work to show that all four of them are right angles. You get one, you get them all. Your second criteria is if the diagonals are equal, then it's a rectangle. So if you have your rectangle and you somehow find out that that segment and that segment are indeed the same, you can conclude it's a rectangle. That was one of those defining properties. Again, we're just looking at them in converse. So for a rhombus, again, if we know first that we have a parallelogram, how do we prove that we have a rhombus? Well, if one pair of adjacent, right next to each other, adjacent sides are equal, then it's a rhombus. Now, apply that to what we know about parallelograms. If these two are equal, one pair of adjacent sides, opposite sides in a parallelogram are equal, and you can quickly see it becomes a rhombus. The second one, if the diagonals bisect the angles, then it's a rhombus. Again, that was one of the unique features. And so if I look at a figure like this, and I am given or can prove those two angles are equal, those two angles are equal, those two, those two, those two, and those two, I can say that it is indeed a rhombus. And lastly, if the diagonals are perpendicular, then it's a rhombus. So if you have that rhombus whose diagonals meet at 90-degree angles, then you know what, if you have a quadrilateral, a parallelogram, you know you can say further that it is a rhombus because of the 90 degrees. That is all of the information for this section. Now we're just going to look at some examples. So for example, given a parallelogram ABCD with diagonals AC and BD intersecting at point P, determine whether the figure is a rhombus, a rectangle, or neither. So I'm just going to take a generic run-of-the-mill parallelogram, and I'm going to name it A, B, C, D. It has a pair of diagonals that happen to intersect at point P. Now, if AC, the whole thing, is equal to BD, the whole thing, what can I conclude? Equal diagonals. If you check on your criteria, that lets me say this is a rectangle. Start over. Part B says, if AB is equal to BC, what do I have? I have adjacent sides equal. Which criteria is that? That lets me say this is a rhombus. Erase your marks. This one is talking about our diagonals again. If I know that BP is equal to DP, that one diagonal is bisected, Is that enough information to conclude that I have a rhombus, a rectangle, or neither? And in fact, that is neither. It is not enough information if only one gets bisected. Okay. Example number 2. Feel free to pause if you need to work the example and then listen. Given, actually, a parallelogram, PRST, determine if I have a rectangle, a rhombus, or a square. So let's get ourselves a picture of some generic parallelogram. PRST. First criteria says that PS diagonal equals RS, or RT, excuse me, equal diagonals. And if I have equal diagonals, I have a rectangle. Now, if I know that that same diagonal PS is now perpendicular to the other diagonal RT, perpendicular diagonals, that tells me that I have a rhombus. And if both criteria are true, equal diagonals and perpendicular, our most specific figure with the most criteria is our square. And so you just need to evaluate what is the given information, which one of the criteria does it meet for naming one of our figures. Now the last 3 examples for this lesson are our true and false. If LM, again, get yourself a picture. Pictures don't have to be pretty, they just have to be functional. L, M, N, P. If LN is perpendicular to MN, then it is a rhombus. Does perpendicular diagonals meet the criteria for a rhombus? True, it does. The next one says, if LN equals PM, if my diagonals are equal, then it is a rectangle. And again, equal diagonals is one of my criteria for a rectangle. And if they're perpendicular and equal, they are a square. So I can ask you to do a naming problem, like example 2, or a true and false type problem, like number 3.